Hello, welcome to the latest episode of AskANerd. Thanks for joining us again. Don't forget to like and subscribe to be notified for future episodes, as usual. When people look at electric cars, they consider that there are less parts involved than a typical combustion engine vehicle, and that this is therefore quite an easy job to go and engineer an EV. It's not quite as straightforward as it maybe first appears. There is a smaller number of components, but making them all work together in harmony is probably one of the biggest challenges of getting an EV to work properly. So today we're going to bring in a nerd to talk about integration of those components. And I'll hand you over to Cecile to introduce our guest for the day.
Thanks, Tom. So I've been lucky recently to try a Polestar. And each time I am inside an electric vehicle, I ask myself always the same question: why we still see this central tunnel? Because actually we don't need that anymore. But we still continue to see what I call relatively classic design. So I thought it was time to ask a nerd, and that's why today we have a special guest. So before we go to technically to our subject, today it's organized as following. We will discuss about the difference between classical internal combustion engine and electric vehicle architecture in terms of the vehicle integration. We will have some specific area of review, the front end, the interior cabin, the battery on itself, of course, and we will talk about the future trend. Meanwhile, Tom will gather some questions and will come at the end of this episode to ask specific question to our guests. And today, our guest is Helen Ali. Hi, Helen. How are you?
Very good, thank you. How are you?
Yeah. Can you present yourself, please?
Yep. So I'm Helen Ali. I am a principal engineer in vehicle integration at Polestar.
And can you say to people how you end up to work in electric vehicle? What is your background?
So my background has always been automotive. So I started as an apprentice at JLR. Back sort of 20 odd years ago. I spent 17 and a bit years at JLR, working manufacturing, package and vehicle engineering. And then I went to NIO, which is an electric vehicle company that's mainly based in China, though I will go into a bit of detail about NIO later. And then 2 years ago, I moved to Polestar, who have an R&D centre in the UK, and have continued my electric journey.
A very impressive career. I'm happy to get you as an expert today. Today we are going to talk about vehicle integration. The first question is, can you talk about what is this job? What does it mean, vehicle integration, and what is your daily things you have to deal with?
So vehicle integration is different across a few companies. So it means different things in different companies. So from a Polestar point of view, we cover package and concepts, sort of cross-functional issues. We've also got ergonomics and mass as well within our company. So from an integration point of view, we work from right up front to all through the virtual phase and starting into prototype phases as well. We work from having the targets that are set very high level to deliver them and integrate them and make sure that all of the systems, so we work with all of these teams on here to deliver basically what the target and the customer wants, but in a balanced way. So for example, if you've got electrical and interiors are fighting for the same space, we will come in and we almost need to know a little bit about everything. I'd probably describe us as a jack of all trades but master of none, but we need to know enough about each area to be able to challenge them. We've also got to think about manufacturing, service, attributes, and we work very closely with design as well to make sure that we can meet that what they want, but also make it feasible.
That sounds a lot of different skills and areas. That sounds very interesting. So what can you tell us to start with this packaging drawing?
So this is a packaging drawing. So this actually is a Velar, so it's not an electric vehicle, but this shows how detailed and how much goes into a vehicle. So all of these dimensions here we are measured. They're all standard set dimensions, which we can then benchmark across other vehicles. Not all of these will be targets because not all of them are as important. Some of them will just be a I don't know, just because we've laid it out that way. But there's some really key ones depending on where the segment is. So we will set out the vehicle. So is it an SUV? Is it a sedan? How big a boot space do we want? And we will set targets at the start and then start to lay out the vehicle. Obviously, between a nice vehicle and an EV, one of the most important things is we need to get an occupant in, as well as all of the components that we've got. So almost the most important thing is the setup of the occupant. So depending on if it's a sports car or an SUV, you'll then start to change where the occupant and where the driver sits relative to ground. Are you having row 2 occupants? Are you having a third row? And we basically need to lay all of that out and start setting targets and benchmarking similar vehicles to make sure that we are meeting what the customers are expecting as well from that type of vehicle.
And what point would be very important here? I mean, the occupant need to get enough space and for their food, and probably with the battery taking some space. But are there very particular key points that are more difficult than others? Or
Key points is it's making sure you can see out the vehicle as well, because it's getting in and out the vehicle, and then once you're in there, it's making sure that you're sitting at a point where you can see over the bonnet and you can see we've got legal visions that we need to meet as well. As you say, with a battery as well, everything gets raised up, so it's making sure that you're sitting on that and you've still got enough headroom, you've still got enough space to be able to be in the vehicle. And again, it depends on if it's an SUV and what you're expecting. Are you expecting a big car, or actually are you expecting that it is quite a small car and you're going to have difficulty getting in and out?
And usually an engineer in a car manufacturer will work on one specific project, or we will get an overview of different things to do in different segments.
Depends on what department you're in. A lot of engineers will work on one part, for example, but will work on that across various different vehicles. Some people will be specific and stay to that vehicle as well and see it through and only work on that side of it. Within vehicle integration, we try and look at things from a platform side as well. So if we're delivering the same parts but on different vehicles, we want to try and design them so that we can reuse them.
So obviously, when you change from internal combustion engine to EV, it changes a lot of things in the term you can integrate things. There are things I think obvious. We can see that it's often said that the internal combustion engine takes a lot of space and the electric vehicle is much smaller, but we know the battery takes a lot of space. There are also constraints, in my opinion, less obvious in terms of electromagnetic interactions that can happen between different components, and sometimes legally you have also to play with what you are able to do for the powertrain. How that translates for you in a vehicle interior?
So from that side, it depends on where we can put things. So we also might have some electrical components inside that we can't place near, even though you might have a structure between it, we might not be able to place things too close to that. There's also sitting on components that you don't want your occupant, or you don't want your passengers to be sitting on a really hard component that comes into the interior. So it's making sure that you've got enough comfort on that as well.
Are there also things like, for example, on an internal combustion engine, I know that the transmission in terms of crash test is very critical, because you could get perfored in case of an accident with something. Are there also considerations like that for electric vehicle?
Yes, but the way that the structure performs is different with electric vehicle, because we've used, so I will come into that a little bit later as well, but because we've basically moved all of the mass and all of the main components to under the vehicle, the body has to perform differently in order to protect the occupant in a front or a rear crash as well, in how they perform. So we've had to design the structures differently to take different loads because of where the mass is now distributed.
I have also the impression that it must be great for someone working in the vehicle integration and in the interior when you have to now work with an electric vehicle, because I have the impression this gives you also much more freedom. Is that globally true?
In some areas it is. So in, for example, the front end, you do have a lot more flexibility in what we can do. Interior wise, it comes with its challenges and its opportunities. Some things it's opened up a lot more, but some things we're still challenged with. So I've put here that with an electric vehicle, we've still got a driver, we've still got a steering wheel in the same position, we've still got pedals, we still have wheels and suspension, we've still got controls that we need to touch. Fundamentally, between an EV and an ICE, nothing has really changed in the interior. We're not at a stage yet where we have driverless cars, or we have um, things that can drive themselves and steering wheels that can move out of the way. So we're kind of almost constrained with those hard points that we've got to work around. But there are some different things, like you said, there's potential that we don't need a tunnel anymore. With a higher seating position, can we get better vision because we can see out a little bit better? The structural performance I've talked about, and then also the distribution of the mass and the distribution of the parts means that we've freed up a lot of space in the rear end, and actually some space in the boot as well, in a way. So underneath, can we take advantage of those bits that we've lost and give it back to the customer, so it's not just lost spaces?
Is there anything you want to point out in this slide about the key differences between traditional ICE and EV?
Well, the main thing is the battery pack is our main thing. So we've gone away from having the power source, I guess, in the front, to then putting all of that and distributing it underneath the vehicle, which comes with its challenges of suddenly we're now sitting on top of a battery pack. So you've gone from having all of your mass and your parts, front and rear, to underneath you. So we're lifted up, but the design of vehicles, so design haven't changed their car. So design haven't turned around and said, oh, electric vehicles need to be higher in proportions. Their design always want to push it to look lower and look racier. So they will still be pushing us that way. And then we've got the battery pack picking up there, and we're trying to still get the same driver in the middle, who is still has to have a steering wheel and still has to have a pedals. So it's trying to optimize as much as possible and think of different ways to do things, and think of different ways that we can lay out the vehicle with this extra space that we've gained.
Then you prepare a slide about the mass and the attributes. What can you say about that and how it is important for you? I know in one of the recent webinars I have watched is that NVH is really critical, because now you have so much noise from the roads, and I know often people can complain about that. So I know there are a lot of technologies. What else did it change for you?
Yeah, so one thing you mentioned is having the motors. So now you've got no engine noise as well, and people's expectations of an EV is that it's silent. But now you've got extra wind noise and extra packs. So the motors make quite a lot of noise as well. So it's extra packs on top of that for NVH to protect it, so you're not hearing it so much, and that then adds extra weight. One thing from a attribute point of view is range. People obviously still have range anxiety of not being able to go far enough until their next charging point. So any mass that we can take out, I've put there that about 10 kilos equals about 1.6k. So with each kilo we can take out, gives the customer.
It's a good order of magnitude. 10 kilo, 1.6k. Does it mean if I lose 10 kilo, I can get 1.6k range?
I don't feel like maybe I should go on a diet. Maybe that will help as well.
I have also seen that some OEM add a specific noise inside the cabin to emulate the noise of an engine. Is that something common, and is that something mandatory for a legislation point of view at some point? Because I know for people who are impaired, that cannot hear, for example, very well, electric vehicle can be a problem, for example.
Yeah, so I think that, as you say, people who are crossing the road, so pedestrians as well, if they don't know there's a car coming, there's issues with people stepping out, and as more electric cars are out, people don't necessarily pay attention, and they need to know it's coming. And then there's, as you say, interior noise as well, and people are expecting to hear something start up, and if they don't hear their car start up, the worry of, is my car working, is there an issue? So it's how we manage that as well, and how we get people's expectations and get people used to having electric vehicles on the road.
So what is the main challenge for you here? I have the impression from what I read, you have really NVH and the weight. Are there other things really you chasing and you are worried about?
So there's one thing is platform axle limit. So a lot of the time, if for example it's not a EV unique platform, it might be then that it's been designed for a lesser, not as heavy vehicle. EVs as a like for like, EVs are heavier than their ICE combustions because of the battery and the extra parts. So it's then adding extra mass can then impact our axle limits as well. So it's making sure that we are designing for that and we know up front what our mass is going to be on between the front and rear axles. Heavier EVs as well are at a risk of tripping into your mass limits. So whereas before you might have an SUV and suddenly we've chipped into the next category and it's now a truck, a 10-ton truck, and they also a light goods vehicle. So that has different legal requirements as well attached to it. And also linked to mass references and axle limits as well is making sure that we're not then saying to the customers you can only carry a certain amount of weight. So linked to the axle limits, you say you can only carry 20 kilos of luggage. That's not going to go down very well if we're putting constraints on people if they can't tow or they can't carry certain things.
And what about the drivability? I mean, cars need to be fun to drive also sometimes. So is that something also difficult to handle with the electric vehicle?
Yes, we've been used to before having, especially with, obviously you do have some mid-engines, so like Porsche has a mid-engine, but majority of vehicles are front engine. So a lot of the weight is at the front. So the way that the car handles is very front biased. Electric vehicles are typically a 50-50 because all of the weight is mainly between the two wheels with a little bit either side of motors. So the way that the car handles is totally different and we've had to get used to how those handle. But actually it kind of means that it usually handles a little bit better because you're not front heavy or rear heavy. And it's just knowing that up front so that we can tune the suspension and tune the dynamics for that.
Many vehicles now get what we call a frunk, and the way you can put your luggage and the way you can enjoy your EV are also different from a classic internal combustion engine. What can you say about this management of storage and the way it impacts your design?
So again, this kind of links to customer expectations as well. So they expect to open up the bonnet and the engine's gone. So they're expecting to see probably a massive frunk, but we still do have lots of items that we've still got to package from an EV point of view as well in that front area. So it's trying to manage the expectations of having a frunk, but having it large enough to be able to use. But we've also still got
just a small luggage here.
yes, I know, and they are. Some of them are actually quite small, but they're still usable. And it's trying to manage what you so you can put your charge cable in there, and a lot of people will put that in there. But we've still got the front end again. I've talked about. We've still got interior. We've still got the wheels, and we've still got the pedals. From a exterior point of view, we've still got wiper mechanisms. We've still got a windscreen and wipers that go at the front, and we've still got washer fluid as well. So we still need to have access to that. So customers and manufacturing as well still need to get access to it. So, but we have utilized any.
You still get a classical trunk anyway, so the frunk is
You do.
additional.
It's an extra. It's an additional, an additional extra that you can have. And we're trying to utilize that as well. I said it could be you could put your charging cable in there so that you don't have to put it in your trunk and your trunk's using. But it's also things like an EV. Do people expect that everything is electric? But then, do we still need a mechanical bonnet opening? In case the electrics aren't working. So there's things that we need to think about that we still, in a way, are still constrained with traditional ways that people use vehicles as well.
Something that have surprised me is that I have recently also learned that you have to acoustically be careful of the frunk. So you also can isolate it for noise because it also can dampen you the noise of the road and things like that. So it's things I believe not obvious, but I was surprised about this.
Yes, because it is a void. You're almost adding underneath the bonnet this extra void that we still need to make sure is not going to give
You
different
mean it can
noises.
be in resonance and create some noise on itself?
It could do if it's not stiff enough, yeah. So we need to make
Okay.
sure it's usable, but also almost structural, but not too structural, because obviously at a crash, you don't want to make it a hard point that you're going to hit against as well.
So now we are talking a little bit more about the interior, and I guess you have tons of things to say here.
Yes. So again, we've so talked a little bit about we're still constrained with our steering wheel, and our IP still remains the same, but we're now sitting on a battery pack. So we've lifted. So here I've got, it's just a quick comparison. These vehicles are basically the same vehicle height, but in a Polestar, obviously you're sitting on a battery pack. So as a quick look there, you can see straight away that the bout height is higher, the window is the header is lower as well. So everything
Mhm.
feels like you're sitting a bit higher and you've got a little bit less room. So we have to be within sort of vehicle integration a little bit better with how we optimize, especially the header area and the cant rail and anything that's above, and make sure as well that we are from the seating position underneath as well, that we're optimizing the stack up from the battery to where the occupant sits. So whereas before we almost had loads of room, we could pack loads of stuff underneath the seat. We've lost that now. So it's optimizing the stack up and making sure we are as optimized as possible, and we've got nothing under the seat other than ducting that we still need, because we don't need to duct if we've got rear passengers as well.
And if we come back to my initial question, why we still keep this tunnel in the middle? Is that something you believe will disappear at some point, or
So
it will stay
that I think I've
forever?
covered in my next slide actually, in that one about
Oh, okay, nice. Let's go to next slide.
So as you said, we no longer have transmission that runs down the side. So do we need a tunnel? No, we don't in the sense, but actually from a front row point of view, we still need this expectation of when driving is we still have an armrest. So we still need to have something there. So if we then put our console in there and we put an armrest, it needs to sit on something. So do we may as well in a way utilize that tunnel to put some battery units in there. So we've got battery units that usually are quite modular that we stack up. If we need to have in the front row area a bit of a tunnel, we can use that to put some battery modules in if we want to. Because if not, it's a difficult space to utilize. So if you look on the picture and you look sort of between the two seats and underneath there, if there was space there, you couldn't put anything down there, because if it rolls over to the side, it could go underneath the pedals and could stop you from operating the pedals. It's not really very easy to access, especially in a smaller vehicle if you're leaning round, and we've still got to think about ergonomics and how people use stowage in the vehicle. So we can make it slimmer, which gives the passenger and the driver more room, but it gives you more roominess, but a lot of the time we will have a slimmer tunnel than we would have done. But where the real opportunity comes is, I think, in row 2, because a lot of the time we will maybe have a tunnel in row 1, but drop down. So whereas in sedans, especially, your centre occupant, a lot of the time you're sitting on a tunnel and it's not very comfortable. Yeah, we don't need that anymore. So our centre occupant now has a much more comfortable seating position. As you see there on the 6-seater Neo, you've actually got a pass through where we now don't need to fold the row 2 seat to get into the third row. You can walk between the two because there is no tunnel. You don't have to climb over anything. So it gives us much more flexibility in how we lay out occupants and how much room you've got in the rear without having a tunnel there that impedes your footroom and your pass through as well from getting in everywhere. So it's almost made it a bit more of a room in the back.
There are also tons of other hidden things. What can you say about the space the occupant can get for their luggage and all the consequences we can see? I guess.
So we've talked a little bit about the so the pictures on the left. You can store your storage there. You can also put some of your legal requirements. So you need warning triangles in some countries. In Spain, you need 2. So you can put extra things there that you need to. As a first look, if you opened up the boot of a normal sort of a traditional vehicle and an EV, you probably wouldn't be able to tell the difference because you've still got suspension towers and you've still got the seats in front. So there's not really much difference, but it's the hidden opportunities. So underneath, we've now not got an exhaust. So can we now utilize that space and have a drop down and have a void in there that we can put extra bits of stowage, and we can have clever hidden bits that we can put I don't know, you put your laptop under there, or you can put a bag under there, or you can put your charging table. So I think it gives opportunities that you might not necessarily see from first looking in.
I know that at the start of not full EV but hybrid, I know a lot of people complained because the battery was taking a lot of space from the boot, so it was not really convenient. But this problem does not exist anymore in full EV, right?
No. So we don't have to put. We still have. We can still have a motor underneath there, but it's traditionally where you probably would have had the transmission and the motors before. So yeah, you've got no exhaust, and you've got no MHEV batteries or PHEV batteries or extra ducting that we needed to package as well for those. So it gives you a lot more flexibility in the boot. Although when you have lost the space underneath the seat, so on some vehicles we'd put electric modules underneath the seats. We don't have that space anymore, so some of them have gone to the boot. So we've had to utilize the space for package items that we can no longer package, where the battery goes as well on that interior. So that's the downside of having of having the interiors as well.
So now we move on a little bit about the constraint on the batteries, which is something I know slightly better because vehicle design and vehicle interior is not something I really know. So I know that Polestar, of course, use a common platform that can be shared across some of the common product inside the group. I also know that you have used now how long have you had this platform? 3 years, something like that?
Yeah, about that, yeah.
What can you say about, or if you would have ideally requirement to ask to people developing batteries, what would be your wishing list in terms of what they should do for the battery pack? Because it would help you to get something better for your vehicle integration.
So one thing you've talked about is having it almost modular, so being able to share it across platforms. So as you say, you've got the way that we've done, one of them is that you've got a foot garage. So if you've got a shorter vehicle, you could reduce the foot garage. Obviously it gives less space for the occupant, but you can still basically reuse the package that we've got. We could, if you've got modular battery packs as well, we can move them around and put them in spaces that aren't necessarily utilized. So I think having a modular pack that we can use across different platforms and various different sizes of vehicles, from a wheelbase point of view, the height doesn't necessarily come into effect on that. I'd say it's wheelbase and length that if we can play around with that would help us from an integration point of view, because we've also got a lot of sort of motors, so front and the rear packages for the batteries as well, are fairly standard. It's just with overhangs, it's just making sure that we can package different overhangs for different vehicles so that all your vehicles don't look the same, basically.
One question I have is that how important is it to get your thickness about the battery? I mean, if I'm telling you that the battery is now 1 centimeter higher, is that really a big problem for someone making vehicle packaging?
Yes. Because of the mainly because if we have so again, it's the stack up from ground line to sort of underneath the battery pack. So if it, for example, we've come in with something that's a 10 mil bigger, do we then come down and affect the ground lines and the ground clearance, which means that again we might not be able to sell it in some markets, or we have to change suspension and lift the whole vehicle up, which then has an effect on the height of the vehicle as well, which we have again targets from a design point of view as well as market point of view that we want to meet. So we can't necessarily, and if we've got a common platform inside, we don't necessarily want to have to then lift everything up inside as well. So it's does the ground move or does the vehicle move? So if that changes late on, it gives us lots of challenges from an interior and an exterior point of view.
It's something I want to mention to the audience. One of our previous episodes, AskANerd episode 3 with David White from Deneca, we talk about the coolant of the battery and how it changed the clearance. And apparently it's very important for you. So it was a good point to discuss that with last time.
And another, sorry, if I just go back one sec, because one thing that that we need to think about is service access as well. So whereas before you'd had all of your components, when you drive a vehicle, it's underneath the bonnet, so you open it up, and from a service point of view, it's fairly easy to get access to things. One thing with the battery is the battery's underneath. So how, from a service point of view, how do we get access to that? And that's been one of our biggest challenges, is making sure that you don't want to have to remove the whole battery or remove the whole interior to get to parts. So it's thinking of where can we have access that's easy to get to, so that it's not going to spend, so your cost of ownership doesn't go 3 days to replace a part. So it's having those access. That's been a challenge.
Maintenance and accessibility is something I discuss a lot with my customer. It's, as you know, a big problem. But I think for the general public, people have the impression that the battery is there and you have no maintenance. You will never get anything to do unless you have to change all the battery pack. But I think it is important people keep in mind that this accessibility is very important. It's a huge constraint. Also, people told me for the electronic, also if they want to make something, they need to be able sometimes to disconnect the battery. Sometimes they need to get manual access. So yeah, I understand it's a huge problem for the design. So now we talk about a little bit the trends we have. So one of the trends you have selected is battery swapping. Obviously, you are coming from NIO, so you are very familiar with this. What do you think? It's a trend that can happen, how it changes things from a game business point of view and your design and technical point of view?
Well, it's totally, from working at NIO, it was I went from working at JLR, where we were looking at traditional battery packs, to then going to NIO, where it's a swappable battery, and it's at the time they were only selling in China. So the battery swap stations were all set up along the highway, so you could drive for a while, and then you drive in, and you can see videos on YouTube where you just drive in, it aligns the vehicle, takes out a battery, puts back in 3 minutes, and I think 5 minutes in total, you're in and you're out. Obviously, when I was there, we were looking at, could we go into Europe? But it's a different infrastructure, because if you're driving, so between in England and you're driving to France, or you're France driving to Spain, if you don't have those battery swap stations, it's the infrastructure isn't there. But since I've left, they have now started to sell in Norway as well.
But you still can charge your car with a plug still. I mean, people imagine that battery swapping works only with battery swapping. It's not totally true. You still can charge it with your own charger.
Yes.
And with the normal fast charge.
Yeah, it's still got the normal charging as well, but it's the option of driving in and out in 5 minutes, and you can swap your battery on a long journey. But the things that brought with it is your battery pack, whereas usually your battery is built as part of the structure, because it doesn't get removed. With a swappable battery, you're basically removing your whole inside, really. So all of your underfloor is coming out. So how do you then stop that structure from collapsing or breaking in that time that it's been removed? So the challenges that was bringing was obviously increasing it down the sills to make sure you're not necessarily loading your battery because it's not there. Having to be able to do that in 3 minutes, be able to having quick release, but also robust fixings as well. And then also a flatter battery pack, as you can see there, and quick release, because the last thing, if it's a bit of a treacherous route up, the last thing you want is to be driving in and then it gets stuck and it doesn't work and it doesn't connect properly, and the customer complaints that you'd have for that would be that. So the design of it had to be around quick, simple method of being released.
And you believe it's not going something that spread, I mean, in terms of trend? I don't have the impression. A lot of people talk about it, of course, but so far I don't have the impression it will come in Europe, at least so much, except NIO, of course.
Yeah. So I think at the moment NIO are the only ones that are looking at it, but I would be interested to see that if it takes off in Norway and then grows from there, whether other companies start to look at swappable batteries, and then how the infrastructure of, you almost want to share stations. You wouldn't want to have a different station for every single vehicle as well. So it'll be interesting to see how it develops from Norway, and which other markets they go into as well. So I'm very interested to see how that develops.
So of course, due to your experience at NIO, you can talk about all things. So NIO gets the EP9, which is a phenomenal hypercar. I've never seen one myself, but I have seen a lot of videos. Want to mention this is one of the rare, I do not know other hypercar, at least that are commercial, that get swappable batteries. So it still gets swappable batteries, but they are on both sides. So you can remove them from the side, and you need mechanical people to change this. It's possible on a track. So for a day, if you are making whatever, enjoying a day on a Silverstone or wherever. Did you work on this car yourself?
I didn't know. So this was before my time at NIO, but we did have, there were a number in the UK as well. So we had a NIO day in the UK and a barbecue, and we had the EP9 there. So I did get to sit in it. It was very hard to get in, and I will say that. And that definitely isn't a 5-minute battery swap as well. And so that was a longer one. But it was fast. It's such a fast car. And I think it was on, I think it got a lap record as well. So it's very impressive car, but that was not designed for, I guess, to go out to markets. They only made a handful of cars. They're not designed to go into sort of mass production, which means then if you're not designing it to be sold generally to the public, there's loads of requirements you don't have to meet. You can make compromises on getting in and out, on roominess, on range as well. It will just need to go around the track a few times. You don't have to have hundreds of kilometers. So there's things with supercars that you can, from an integration point of view, you don't have to think about on a general vehicle, which means you can make it look totally different to one that you would sell.
I think it's interesting you mentioned in the train super and hypercar, for the fact that even, of course, it's not something that sells a lot of cars and it's a luxurious product and so on, but still in terms of what it represents in terms of image, you can see that even the luxury car, like Ferrari and Lamborghini and so on, they have now, and we see that with the 2035 legislation, they will have anyway to move on to electric cars. In terms of their packaging, in terms of their design, it's also going for them to be quite challenging, I imagine.
It is, yes. I was just see again how, but then I guess a Lamborghini versus a Polestar, for example, will probably have a different market. So it'll be interesting to see how they design an electric vehicle for the general sale as well, a sports car.
I follow that, of course. Without talking about this massive super and hypercar, we still have sport car, and obviously Polestar is still a sporty brand, I would say, in some segment at least. Are you working on that? What can you say about this?
I can't say too much, but we obviously a few months ago released, that's the O2 concept at the start as well. So that's a retractable hardtop convertible as well. So, and since we've released that as well, there's been Fisker and Tesla have both sort of released retractable hardtop roadsters as well. So I think the trend is EVs now looking at, we've had SUVs, we've had sedans, so we need to push it further now that we're learning more, and sort of battery technology is getting slimmer and range is getting more. We know more now, so can we start to design different vehicles that, the challenge there is, as you can see, the roofline is so high, and now you're sitting on a battery pack, you're sitting higher. How do we get the low sports car feel and the low position and the low to the header while sitting on a battery pack? So it brings with it its challenges, but yeah, they look fantastic. So we've just got to deliver them.
That look a fantastic opportunity for people in vehicle integration, because if you have so much constraint and such things like the roofs that can be folded and everything, to end up with everything you have explained before, well, you can have fun for a long time, I guess.
It's different every year. Every year we get different things to work on. So it's never boring in integration, and never boring in automotive actually, especially with different trends that are coming up.
So we are close to the question with Tom. We still have some few things to discuss about what are the challenging you can see now in EV and what is going on. So obviously people talk about the range anxiety. I think personally it's better because we see cars now that can start to make like 1,000 kilometers. So I think this discussion about the range anxiety is going to go away at some point. But we had several people coming to AskANerd talking a lot about fast charging, and fast charging is still one of the difficulty. What else do you want to mention here? You see as a challenge for yourself?
So I think as we're learning more as different markets are taking electric vehicles as well, each market will have its own requirements, and we have that already with different markets have different legal requirements. And I think for as more are adopting EVs, they will have their own requirements. So we've got to make sure that we are, because we're designing vehicles that are coming out in 4 or 5 years, we need to be aware of what is coming and make sure that we can react quickly to make sure that we're integrating those and changing those as we're developing the vehicles and designing them. Another thing which I've got a couple of slides on is sort of end of life requirements as well. So with EV, one thing that links closely with it is sustainability and recyclability.
More and more. I think in terms of legislation, it will anyway be mandatory at some point to give a full LCA of your car. So we hear that more and more.
And Polestar 2 we've released a full LCA as well.
Yeah, I think honestly, the Polestar studies, the LCA, in my opinion, is very good. I have worked on it a lot, and it is very reliable. If I compare to some other, I know I would not mention any name, but I think the Polestar is very reliable.
Yeah, we've got a really good team on LCA over in Sweden as well, doing that side of it.
Well, as you mentioned, sustainability is really a trend. We see a lot of suppliers, of course, taking sustainability as a selling point. And we also see like Neo Day, they talk about these new materials that are natural with new fiber and so on. Is that also a trend you have at Polestar and everywhere you see?
Yeah, so we're constantly looking at new materials, more sustainable materials. And some of the challenge of that is obviously they need to meet, depending on if it's an A surface part or a B surface part as well. So whether the customer sees it or it's a structural part, they need to meet automotive requirements. So if it's a structural part, it needs to make sure that it's going to meet the durability test of that. Also, if it's a material that is, we're saying is sustainable, we need to have traceability on it. So if we have this really great material that's made from a sustainable source, but actually it gets transported to us in a really unsustainable way, or is processed in an unsustainable way, is that really? We need to have the balance there as well.
A lot of material are recyclable, but do you use a lot of recycled products? I mean, for example, the carpet, can you embed some recycled products, things like that?
So we try to use, so some of our materials that are coming up, we'll try and use recycled parts from other bits that we use that will then be, I don't know, so our carpet is made from, parts of the carpet will be made from offcuts from other parts of a vehicle as well. So we try and reuse as much as possible. But it's also, I've put there as well, so design for sustainability, but also it's designed for manufacturing as well. So if it's a sustainable part that's more lightweight, does it then need more fixings? So manufacturing don't necessarily want to fit 20 fixings when they could fit 3. So it's trying to have that balance as well between manufacturing and making a sustainable vehicle.
Okay, so now I think I hand over to Tom, and I will let you discuss a little bit.
Thanks, Cecile. So I guess now we know that integration is a very important role in bringing everything together, speed dating all the engineering teams together to get to a nicely balanced output. We do have a few questions, one of which is around in-wheel motors. So why are there not more in-wheel motors? I guess most people perceive this idea when you first talk about EVs, visioning the concepts of skateboards with wheels in the corner. So I guess maybe I'll ask this slightly different and say, well, what might be the trade-offs of having in-wheel motors in the packaging space or integration space?
Gosh, well, I guess it's the standard layout that we've got with how much room do we have with wheels and suspension and links. Is we've still got a standard layout. So yes, we've got electric parts and we've got motors, but fundamentally our springs and links and suspensions are still they've not developed alongside at the moment with EVs.
Yeah, so I guess it's still the same but different, as you were saying, in terms of the detailed execution. Yeah. The other one is, I guess, looking at the integration of components. So given that stack height we have to fight with in terms of the package, I guess Tesla's the example here in terms of integrating more of the battery functionality potentially into the body in white. A bit like Cecile was mentioning with regards to the cooling as well, trying to reduce that Z height. Do you see more of that kind of thing going on in the fight for space, more integration of components or like dual function components as well?
Yeah, and not even necessarily EV components as well. It's some of the other electrical components that we're trying to reduce the amount of modules we've got to package and the amount of functionality into. It could be a slightly bigger module, which then gives us, we may have deleted 3 and put it into 1. If that one is bigger, we've only got 1 home to find, but it's a bigger space that we then need to fight from a package point of view. So we are trying to integrate as much as possible. And from an electrical systems point of view, it's so key with having the harnesses and having it all linked up as a system. We're trying to reduce content because that also then reduces weight as well.
Yeah, win-win on the weight reduction front.
Yeah.
The other one I was going to ask about is Fuss Garage. So the foot garages, which we see in the Taycan as well, the VAG platform. What are the challenges that come with distributing the battery as well? Because I guess there's a trade there in terms of additional cooling and distributed cooling and other systems too. Yeah,
because you're basically putting a break in the battery to have it. So then do you go back to having almost a mini tunnel? Because then when you have to link them up, then you put the tunnel again where we've talked about you don't need a tunnel in row 2. Do you then put it back in there? And also with removing them from there, where do we put them? So do we put them underneath an occupant or do we take it away with boot space? So it's the trade of having a foot garage that is more comfortable for you sitting in row 2 to you've just lost some boot space or you've now sitting a little bit higher on more batteries.
Yeah, because I guess the detail there is that the trade is posture, isn't it? So without them, you tend to sit with your knees a bit more.
Knees up into your face and up into your stomach. So yeah, and also I guess it depends on what type of vehicle it is as well and what the expectations are for that vehicle. I don't think I'd be happy sitting in an SUV with my knees up into my face.
Different attribute trades, a bit like you were saying with the EP9. Yeah.
Yes.
Different cars for different purpose. And the final question was about charger locations. So picking a charger location, I guess, is quite an interesting one. We've seen recently Tesla open their supercharger network to other vehicles, which has been a bit problematic for cars that the charger doesn't quite reach. It's said, I think, that putting them on the front of the vehicle can be quite useful for pulling into spaces, but I guess there's also some trades with doing that in terms of crash, maybe.
Yeah, we have ours at the front because that's where the majority of our charging parts are as well, so it needs charging. So it's also thinking about the route. So if you put it at the rear, which is obviously from a fuel tank point of view where people expect to be charging, if all the components that you're charging are at the front, you're then again adding extra mass and weight and extra cabling to run from one to the other to charge it. So it depends on the layout of the vehicle as to what your shortest route is. And again, that could be different for different vehicles depending on where they've got the space.
It's all one jolly big compromise, isn't it?
That's why we've got the vehicle integration department.
Absolutely. The team that brings it all together.
So thank you, Helen, for joining. I've learned tons of things today because, as I say, vehicle integration, I was knowing very little, and I understand it's more interesting than everything I can imagine.
I was hoping
before.
it got you to think differently about how a vehicle is set up and how a vehicle gets integrated and built as well.
Yeah, it's been very good.
Thank you for having me.
Thanks for your time, Helen. Yeah, thank you. Thank you. And thanks, Cecile. Don't forget to check out our other videos on YouTube, and we'll be back again soon with another one.
Okay. Thank you. Thanks, Helen.
Thank you.
Bye-bye.
Bye-bye.
Bye.